We'll start with the Jongno game first and myself, and then we go on to discussion session. All right. Any question on schedule or other items? And also afternoon 1 p.m. as a regular classroom. Will be in the classroom physically, and we'll cover the ship hydrostatics in the afternoon. And next week will be a midterm exam, but I will be away from the Korea, so I will not be available, but it will be okay with the TA. Right? So let's get started with the Jongno Kim lecture.
화면 다 보이시나요?
예.
Hi everyone. My name is Songno Kim. Today we are going to study dynamics of ship motion. Our content starts with cause and type of ship motion and Q&A. In the middle, uh, we will have a short quiz time for with 2 questions, and to review we learned. First, cause and type of ship motion. When ships sail on the ocean, various forces act on these various force is like wave, wind, propulsion, or rudder. These various forces create the motion of the ship. There are 6 types of ship motion. These 6 motion include 3 types of translational motion and 3 types rotational motion. This motion can happen at the same time, but we usually study them separately. Today, we will focus on rotational motion. First is rolling. This ship and ship axis. Rolling is when the ship rocks side to side along its longitudinal axis, like that. This mainly caused by wave heat of ship. The negative of rolling include possibility of capsize and damage to cargo and crew fatigue and reduced efficiency. Rolling is also cause a major cause sea sickness. Methods of rolling stabilization are vehicle and anti-rolling tank and stabilizer pin. Next slide is let's watch the video to learn more stabilizing rolling.
we cannot see the video. And also there is no sound. So you need to unshare the screen first and then share again with
Ah,
the audio options check.
okay.
And also probably your window probably different for the video play.
아,
You need
오케이. 뭐지? 이거 안 됐나? 아,
unshare first, unshare. The
오케이.
screen, zoom unshare, the red button.
어,
빨간 버튼으로 화면 공유 정지부터 먼저 하시고,
화면 공유 좀, 예.
다시 공유하면서 왼쪽 밑에 있는 오디오 공유 버튼을, 옵션을 눌러줘야 돼. 화면 공유 초록색 누르면 왼쪽 밑에 오디오,
혹시 들리시나요? 혹시?
비디오 나가?
Cruise ships build
아니야, 들립니다. 네.
예. 알겠습니다. 다시 화면 쓰겠습니다.
stabilizer is to keep the ship upright as waves pass underneath it by counteracting the force that the waves create. However, this force is not constant as the crest of the wave moves across the ship, causing the tipping force to vary. The stabilizer must be able to adjust the amount of force it produces in response to the constantly changing position of the wave in order to effectively keep the ship stable. The ship industry has developed several types of stabilizers that can be classified into two categories: active and passive. Bilge keels are an example of passive stabilizers. They are protrusions on the hull of the ship that help to dampen rolling by creating turbulence as they move up and down. While they are effective at reducing rolling to some extent, they are not powerful enough to adequately counter the forces that can cause a cruise ship to tip. They are an inexpensive option, but are not suitable for use on cruise ships. Bilge keels are commonly found on other types of ships due to their low cost of installation. Another method to prevent rolling are passive anti-roll tanks installed at the edges of the ship. These tanks are connected by crossover pipes that allow fluid to flow between them. When the ship tilts in one direction, the fluid in the lower tank increases, adding weight to that side of the ship. If the flow of fluid can be controlled properly, it can help to counter the rolling motion as waves pass underneath the ship. This system can be made semi-active by adding additional controls, or it can be made fully active by adding pumps and a gyroscopic stabilization system to pump fluid between tanks as needed. While fully active systems are effective at stabilizing ships, they do have a delay in their response time and may not provide instant stabilization. So, what is the best stabilizing system for a cruise ship? Fin stabilizers are the most commonly used system for these ships. They consist of hydraulically operated wings that extend underwater and can be adjusted to change the direction they are facing. This allows them to counter the rolling motion caused by waves or other factors. Fin stabilizers are similar in appearance to bilge keels, but they are able to change the angle at which they are facing, which bilge keels cannot do. When a fin is rotated, the direction of the force it creates in the water changes. By turning it one way, a large force is generated in one direction. When it is turned the other way, the direction of the force is instantly reversed. By using gyroscopic control to properly adjust the angle of the fin, it is possible to counter the force of the waves or other factors that may cause the ship to roll. This allows the fin stabilizer to effectively stabilize the ship. One disadvantage of fin stabilizers is that they require the ship to be in motion and have a minimum water flow speed in order to generate a sufficient righting force. Below this speed, the fin stabilizers may not be effective at stabilizing the ship. Most cruise ships have sufficient speed for fin stabilizers to be effective, so they are not a concern while the ship is in operation. However, cargo ships generally have slower speeds and do not typically use fin stabilizers. There are some container vessels that do use fin stabilizers, but only if their typical cruising speeds are fast enough to fully utilize their benefits. I hope
오케이.
Videos of
Next is pitching. Pitching also is when ship lock forward, bow and stern, forward and backward along its transverse axis, like that. This happens mostly when ship moves head-on wave. The negative effect of pitching, deck flooding, and propulsion engine damage, and slamming. Slamming means when ship bow is lifted by wave, this or sea, and drop back down, it hit water hard. The best way to stabilize pitching is changing in ship course or speed. Next video is about how dangerous pitching can be. This video shows first deck broke by pitching.
Mayday, this is motor vessel Arvin, Mayday, my vessel broken, my vessel, Mayday, Arvin.
Тонем, съебуй!
Mayday, this is motor vessel Arvin, Mayday. Arvin, help me, Mayday.
Fortunately, this ship was capsized. Okay. Next is to avoid rough sea is always best, but if you can't, here how to handle this situation. On a diagram, the right side is dangerous semicircle in storm, and left side is navigable semicircle in storm. There are two ways to sail in a storm: have to and scudding. First, have to means this ship and bow and stern. Have to means facing the wave at 1/3 of the ship bow. And scudding means face wave the 1/4 ship stern. And use best method for the situation to ensure safe sailing. Last, yawing. Yawing is when the ship rotate right and left at vertical axis. This mostly seen when the ship move toward. The negative effect of yawing cost deviation, possibility of collision with other ship, and broaching. Broaching means lose control of ship and suddenly tilting or spinning. And to stabilizing, yawing method is trained by the stun and yawing detection and control system and Lanti Yoskek. This video about broaching. Let's watch the video. This ship is yacht. Suddenly tilting and spinning.
Yo, doing a roundup. Whoa, big roundup. Right in front of the yacht club.
Okay. In extreme case, ship can be capsized. And this picture, yellow circle shows where the anti-yoke skeg is located. Skeg help stabilize ship by providing resistance and reduce yawing. Also, skeg protect propeller or rudder when ship hit shallow sea or obstacle. So now each quiz time, please please answer to use Zoom chatting to message chat. First question is, vehicle is there to stabilize what motion of ship? I will give you time, 10 seconds. I'll finish. Correct. Physical is to stabilizing for rolling. Yeah, roll. Correct. Next quiz is what motion of the ship cause slamming? It also give you 10 seconds. Okay. Right. Oh, correct. Slamming can cause by pitching. Correct. If you if anyone wants to learn more slamming, feel free to watch this video. And thank you for listening to lecture. Are there any questions?
Thank you very much.
Oh.
Nice quiz, and also video is good. So we can move on to next topic then.
교수님, 공유 중지하겠습니다.
Thank you very much for your nice lecturing. All right. Next is my turn. But I found that I sent to Jongno. Probably I may be wrong to sending a same lecture material as mine. So I switch my lecture material to different one. So you may be not having this one because this is old slide set from 2 years ago. Because of my mistake to sending to Jongno the duplicate material slide set. So I switched my slide set to old one. Please bear with me, and then I will send you this slide set later after the class. So this one is the front part of the Jongno's one. Jongno's one is the second. So we are covering this book. And the chapter is about dynamic stability. And then afternoon we will cover the previous chapter of static stability. So the sequence is also reversed. So I'll cover the dynamics of ship motion and ship motion itself. And Jongno already covered the rolling, pitching, and yawing, and he did not cover about feedback control. So if I have time, then I will cover a little bit about feedback control. So kinematics and kinetics and dynamics, it looks similar maybe to you. We already studied this one in another courses, but let's remind that kinematics is about only description of motion. So with no cause of motion is considered, explained. Only explaining the motion or description. The reason of motion is forces. Right? So kinetics, the second one, kinetics is studying about reasons, the causes of the motion. That is the reason is the forces. That is the external forces and moments that create motions. So by combining.
교수님 화면 공유가 안 되고 있는 것 같습니다.
Oh, sorry. Sorry, I did not. Sorry again. Start again. Yeah. This one is old material, but I will send you this material to you later after the class. So we are covering this book and chapter dynamic stability. In afternoon we will cover static stability. So I will cover this one, dynamics of ship motion and ship motions. Jongno already covered the rolls, pitch, and yaw. And feedback control may be covered by myself after, if we have time. So there are similar wording, kinematics and kinetics and dynamics. Kinematics is considering only the description of motion, not considering about cause of motion. Kinetics is more related to the relation between the motion and cause of the motion. So cause of motion is external force. So dynamics is combining together. So probably you had a separate class about dynamics. I just remind you about this wording terminology. In ship, the same motions, the same dynamics, but the object of motion and the surroundings environment is different. It is very similar with car, automobile, or on airplane. So it is a 6 degree of freedom of motion. So there are 3 translational motions and 3 rotational motions covered by Jungno. And so they have a different names, same picture as previous. Rolling, swaying, yawing, pitching, heaving, and surging. Okay? So same category of translation and rotation, different views. You see that the names are very unique, especially surge, sway, or yaw is very rare to you. Maybe you may have a first time to heard about this wording, terminology. We can use this one to any motion of automobile and especially for the airplane. They use the same wording. Right. So we will see the 6 of degree of motion. This is a pitch. This is hip and surge and yaw and sway. So translational and then 3 rotational, right?
A tugboat is a specialized maritime vessel designed for towing.
So we can see how the equation of motion. So translational equation of motion is force and ma. You remember this F equal ma. So it can be P can be a motion of the ship. That means a derivative of time. So acceleration is related to the acceleration. Simply, you can see notation can be simple. And rotational equation of motion can be simplified as m. M is a moment, external moment, and h is a rotational velocity and derivative of. So acceleration, rotational acceleration. Simply, you can say, and it is the pictures showing that translational motion and rotational motion in the right hand side combined to give you a 6 degree of freedom motion. And symbols, you can use different symbols, but he is saying the standard symbols are here. And also the coordinate, you may put the coordinate fixed on world coordinate system or body fixed coordinate system. But in ship motion, also airplane, they usually put fix the coordinate system on the body of the ship. So it may create another differences when comparing to the world coordinate system. And forces F and moment M and linear velocity translational angular velocity and x-axis, y-axis, or z-axis, XYZ, KMN, and UVW, and PQR. That is a standard notation. Now, it comes with a 6 degree of freedom of motion equation. Mass center is a CG, center of gravity, mass center, and the principal axis of XYZ. So surge equation can be like this one, and sway equation, a heave equation, and roll pitch yaw. When you see the surge and X equation, you see that F equal MA, right? So F is X, large capital X. M is the mass of the ship, and A term is not simple as a single object because ship is very complex, and also there is a motional effect or acceleration comes from the combined effect of other motions. That's why they have different terms like R, V, and QW. You see that R is from here, okay? Angular velocity in z-axis, and V is a y directional velocity, linear velocity, a combined effect, RV, and QW is in this combined effect, cross terms. Z linear velocity and Q is angular velocity in y-axis, around y-axis. And also each term can be very complex if you're trying to calculate this yourself, because ship is very big, especially the M. M is a mass. The total mass of the ship, you need to calculate all of them. Millions of pieces of the ship pieces, and also but basically the equation is same as F equal MA style. Now they are trying to combine them into total matrix type of equation. So force is a moment, and then they are combined into hydrodynamic forces and moment, hydrostatic forces and moment, second term. And third term is control steering forces and moment. And then finally fourth term is environmental disturbance. So wind wave belongs to this fourth term, right? And control steering comes with something like a rudder and other fins and other thrusters. Those are included in third. So real equation is very complex, but it is shown as a simplified form. Then how can you find the derivatives of parameters for this each values, each functions? There should be equations of parameters, and they can be measured or calculated using model test. At the top there is a model test, and model is fixed to the carriage. So we call this is captive model test. And also there is a static test and dynamic test. And also free running model test. This one at the right bottom, it is a free running model test. This model means small scale test, but same as the ship in the ocean. And the left bottom is sea trail. The real ship is tested. So for the testing, there are many different tests going on for each ship, because it is important to know the performance. And control forces coming from the ship is thrusters and control surface. In thrusters, there's a propeller, and also ducted propeller there, and tunnel thruster and bow thruster, water jet. This is a propulsion systems. And then rudder and fins are the other. Rudder is shown here after the behind the propeller. And duct is surrounding the propeller. And you see that skewed propeller of submarine. You will see in the another class why the propeller is skewed. Skewed means curved like this. There's a reason, and this is coming from the Sewol disaster. But you can see that black circular hole in at the bottom of the ship. This is a bow thruster tunnel. Inside the tunnel, there is a small propeller inside. To move the ship in lateral way, the bow and right and left, and near the port, you can use this bow thruster to change the directions easily. And environmental forces are coming, the wave and wind and others. And wave is coming in different directions. Also wind too. And current is another forces, streaming. And also propeller and rudder forces coming that create many different motions. Complicated 6 degrees of freedom. And nature of ship motion, rolling and pitching and heaving are very similar to pendulum. You know about pendulum. Pendulum, I will show you. This one is a pendulum. This looks like a pendulum-like nature, similar due to the gravity-induced restoring forces. We call this one as a hydrostatic spring. You can imagine the spring mass system of vibration, spring mass vibration system, and the hydrostatic buoyancies work as similar to spring. That's why we call this is hydrostatic spring. Also, in other words, is gravity in this restoring force. But yawing and searching and swaying motions in horizontal direction, surface, so that there is no gravity forces application. So they have a similar but different, like not quite the same as rolling and pitch. So you may remember the pendulum motions and natural frequency. This equation of natural frequency is the same and applies to same to ship, and also mass spring system, the vibration of mass spring, same equation, same nature, same dynamics, but only difference is complexity, degree of freedom, and also the objects, the components of the object is complicated. So rolling periods, the ship's natural period of rolling can be predicted by this relationship of GM and K. K is a transverse radius of gyration, something like this. And also approximation can be holding using the B or K, but the above one is more complicated and more reliable estimation or prediction. And serious situation, the resonance. You remember the resonance problem in vibration or sound. Resonance may occur first because of dynamics. So repeating perturbing forces come along and frequency that coincide, same frequency, and then motion can be big, right? And so rolling build up, sometimes it can capsize. Otherwise, you should change your direction of motion of ship to escape from the resonance. Okay, that's it from me, and then I can show you a little bit about this one is I sent you last night, similar to Jungno's slide set, but true slide set is about stability, directional stability. So there is a straight line stability, is the dynamic stability, not static stability. We'll see in the afternoon. For directional stability and also positional stability. This is for when you want to, what is your intention? You want to change the direction and go straight, as same as the change slide, that we need to have a straight line stability. Or if something has a disturbance by blowing of wind, but I want to don't want to change the direction. So then it can be a directional stability. Or positional stability, even though there has been a wind blow, but I want to be coming back to the original course of trip. So these kind of things, maybe depending on our intention, you want to make it a stability or dynamic stability. And also there is a stability and maneuverability is something in against. Any stability looks like this shape, right? We will see in the afternoon more on this type of stability. But stability is ability to returning back to the equilibrium state after external disturbance. Disturbance can be anything, wave or wind or a propeller or something other thing. For maneuverability, the capability of moving a vehicle out of this equilibrium state to a desired state. But desired state can be different. Something like this one. Which one is your desire or intention? Different, right? So desired state. So anyway, handling of a car is same as a maneuverability. Cornering, we can say cornering or handling of car, same as the ship. But they are saying that there is a relationship between stability and course stability, we can say. Course stability rather than just stability. And stable vehicle tends to stay in equilibrium and not easy to maneuver. Maneuver is a maneuverability. On the other hand, so they have a against, not the same there. All right. That's it on my side. Any question? Sorry for the confusions of slide set. I should share you. All right, then we can move on to discussion session. Okay, Yang?
Okay, can you guys hear me?
Yes.
Okay, good morning everyone. My name is Taeyang, and Today I've prepared a discussion session on the dynamics of the ship motions. And even though you might be tired and a little bit sleepy due to the morning makeup class, but I ask you guys for the active participations. So the topic is the dynamics of the ship motions. The content as follows. First, I want to talk about the small lecture review, and I prepare some small quiz, and the last one is the topic discussions. So as you guys learned, we learned about the 6 types of the ship motions. The first one is the pitch. The pitch is the rotational motion around the lateral axis. So where the ships, the bow and stern, rise and fall, affecting the ship's angle in the water and the oceans. And number 2 is the rolling. It's also the rotational motion, but it's around the ship's the longitudinal axis, cause it to leap from the side to side. And the third one is the yawing, also the rotational motion, but it's around the vertical axis, and it causing the ship to turn, the twist left to right, affecting its directional heading. And the fourth is the heaving. Heaving is the vertical motion where the ship moves up and down from the ocean plane. So in response to waves or external forces to the ships. And the fifth is swaying. It's a lateral motion where the ships shift from side to side when on the top view, left to right. So it's typically due to the wind to the ship or the current. And the last one is the surging. So it's also the longitudinal motion where the ship moves forward and backward along its course. So the important thing is the surging influenced by the waves or the acceleration or proportion to the from the ships. So next is the types of the stabilizations. The first one is the bilge keels. So the bilge keels is the long fins attached to the hull and the bottom and the side from the ships, and it passively reducing the rolling of the ships by creating the hydrodynamic resistance. And it also slows down the ship's rolling. And number 2 is the fin stabilizer. So it looks same with the bilge keels, but it's retractable fins that actively generate the lift to the boat and to counteract rolling. So it also providing stability in rough seas or the oceans. And the next one is the anti-roll tank. The anti-roll tank is a tank filled with the liquid or the water, and this water that moves into opposite direction of the ship's roll. So as you guys see, when the ships roll to the clockwise, the liquid moves to the right, and if the ships roll to the anti-clockwise, the water moves to left side. And through this reaction, it reducing the rolling motions of the ships. And the last one is the rudder roll stabilizations. So it's the most conventional stabilization system. So it used the rudder already existed. So with the rudder motions, they adjust the angles of the boat and generate forces that the counteract of the ship rolling. Okay. So the next is the quiz with the OX quiz. I prepared the 4 simple OX quiz. So please everyone in the class use the chatting in the Zoom to put either O or X. So the first quiz is the ship's motion that rotates around the lateral axis is called roll. I'll count 10 or 20 seconds. Okay. Okay. Oh, thank you. So the first question answer is the X. So the sheet motion that rotates around the lateral axis is called pitch. So the roll is the longitudinal axis, the rotational motions. So number 2 is the surge motion occurs when the ship is propelled forward or propels forward. Okay, I count 10 to 20 seconds. Okay, thank you. The answer is yes. The surge motion is when occurs when the propelled or the propulsions. And number 3, the anti-roll tank is a device designed to reduce roll. Okay, I'll count just 10 seconds. Okay. Thank you. Also, yes, the anti-roll tank is reduced roll. The stabilization system is for the reduced roll. And last one, the bilge keels are mostly retractable devices. Yes, that's right. The bilge keels are mostly the fixed devices, and some pins stabilizers is for the reducing roll is retractable devices. Okay, next is the topic discussions. Sorry, I have the 2 topics to discuss today, and I understand that it might be challenging to have a smooth discussion in the online class, but if you have any thoughts or the idea on the topics, feel free to speak up, or if you're unable to use the microphones through the laptop, write your opinions on the respond to the message through the Zoom. Okay, the first topics is which of the 6 types of the ship motions is the most dangerous for ship operations? This question is, there's no right answer, just feel free to respond. Is it okay with the tiny reasons? I'll give you the 30 seconds. Just 1 or 2 answers. Yes. Please with the little reasons about the answers. There's no the right answer. Just put some idea, like I think it's like that, but I don't know. That's fine. Okay. Okay. There's 2 answers from the Lloyd Anthony. The answer is roll, but the reason is if the ship rolls too much, it can the capsize. Okay. And the second answer is from Song Ho Han. He answered pitching because it can cause the slamming, explaining Jungwo's lecture before. So there's no answers, but my answer is roll, because the ship is vulnerable to roll due to the long and narrow hull shape, and the roll increase the risk of the capsizing with the severe rolling. Yes. And the third one is the most stabilization system, like when I mentioned before, is designed for the counteract of the roll. So I guess the rolling is the most dangerous things of the 6 types of the ship motions. Okay, next topics. Is it if you were to invent your own stabilization technology for ships, aside from the 4 existing stabilization methods like anti-roll tank and fin and bilge keels and rudder, so what would it be? So there's no need for concrete proof like yeah, just brainstorm ideas. Is it fine? Everything's fine. The question is if you were to invent your own stabilization, what would it be? Is it okay with the small answers? Just 1 or 2? So for the hints of the idea, the existing some stabilizations like some kind ships use like a gyroscope something. Okay, thank you. The answer from the Lloyd Anthony. Retractable second hull. That way you can increase stabilizations by extending it out or increase speed by retracting it inside. So it's like a retractable second hull from the body and reducing the roll from that. That's a good idea. So for this question and the topics, so my answer is like this. So placing a rotational column on the ships to generate the Magnus force, you guys know. So with the ship's yawing, it can stabilize the yawing motion during its rotation. So it means when the ship's yawing to the right and turn the column to the anti-clockwise and make the Magnus effect to the left, and it can stabilize the yawing motion. So this is my idea. Okay, thanks for the participation. That's all for my speech. Thank you. Sorry, there's another the answers. I'll introduce. I think it would be good to use the gyroscope inside the ships to act in the opposite direction of the rotational force. Okay, that's a good idea too. Okay, that's all. Thank you.
All right. Thank you for your nice discussion session. Good quiz and topics. All right. So, any question or schedule? We can see at the classroom this afternoon at 1 p.m. Right? Is it? See you on classroom at, yeah. I'll close the session. Thank you very much.